All right, so we're going to go ahead and start the talk here while I have the WebRTC going, and then we'll switch to our slides in a second. My name's Arin Sime, with co-founder of a firm, AgilityFeat. We're based in the U.S. and Central America. My co-founder here, David Alfaro, is from Costa Rica. And on the line here, we have Alan Naranjo in Costa Rica right now. Alan was the main developer behind the little tool that we're using to demonstrate some of this. So I'm going to keep him open in a chat as well. And we also have our UX lead here, Mariana Lopez from Costa Rica, who's going to speak to some design considerations later. But what we wanted to do in this talk, so Alan, I'm going to hang up on you here and let's stay in the appear.in session. Okay?
All right.
Okay, so what we wanted to do in this little talk is talk about what we've learned using WebRTC over the last 6 months or so. We've gotten really excited about it. This tool was our first real experiment in using it. We have done a lot of development projects that have some sort of a real-time messaging or real-time data component to them. So when we started getting tuned into WebRTC last year, we were really excited about the possibilities that it adds for not only video and audio chat, but also peer-to-peer data communication as well. So we'll talk about all that more in a minute. Like I said, we are in Costa Rica, and enough taunting about that. So we built this little app that does some real-time messaging as well as WebRTC in it. And David's going to, if you want to log into it, well, in here, like Mitchell did, feel free. It's webinar.agilityfeat.com. It's only going to work reliably in a Chrome browser, which is something we'll talk about with WebRTC.
And because this is a real-time session, we are using a real-time tool that we built just for this session too. It's, as you can see, if you go to that URL, you will be able to give us your comments. And also, you're going to be able to see that as I am passing the slides, in your device, you will see how the slides pass at the same time.
Work for the Wi-Fi, you know?
That will work, but I haven't tried that.
So you will be able to see in your devices how the slides pass, and also you will be able to rate how the conferences go. And also you will be able to see and post comments in this. How can we do this? See, here you are the rating process and the comment process. We are able to do this so far because we are using PubNub. PubNub is a real-time messaging system that is centralized. Now, it is centralized because it means that there is a server that is publishing a channel in which I, as a presenter, can send a message to that channel, and you, as people that are subscribed to that channel, can receive the notification that I just changed the slide. So it is just communicating short messages that the application needs to give them a semantic. It is an event or it is a command. So in this case, if I pass the slide, I'm giving a command. So I, in my application, need to create that semantic and act accordingly. So again, it is centralized. Why? Because the server is managing how all the communication is happening. The difference that WebRTC is bringing to the table is that we are not going to use a purely centralized system. We are going to do a peer-to-peer system in which I'm going to provide the ability to the peers to talk one-to-one without having a server to managing all the communication. So again, before WebRTC, what we had was that the immense popularity, I mean, super popular behavior or tendency that we were having with real-time communication. And we saw as company that PubNub was at that time leading the charge on having a very successful, scalable system for messages, real-time messaging. However, when you think now, okay, I want to share audio and video streams, now things are becoming more complicated. Scale something like that, it becomes a little bit more complicated because it's the bandwidth and managing all the streaming and coordinating all this amount of people becomes a problem. The idea with WebRTC is that we still have a server, but just for doing the signaling. What is the signaling? Signaling means that I need a way from I, as a presenter, or as a person that is having my computer in states. I have a name, I have an ID, I have an IP, and I have a port. And also I have a specific set of codecs in here. But I, as a peer, I want to talk with Alan that is in Costa Rica. And he has his own IP, and we need to traverse NATs and firewalls. And he has a specific set of codecs too, as well. So we need a process in which I can make those things available as possible communication candidates, and then pick the right one, and then with I have the right match of candidates, I can start the communication process. Grabbing the stream, I mean my audio and my video, and then sending that to Alan. And once that starts, we are having a peer-to-peer communication. But before that, I have to do signaling. And the signaling is done by the server.
So you notice whenever you do a WebRTC call, the browser's asking for permission to allow or deny, so that you can't just, spy on someone, in theory at least, through this, right? They are required to give their permission. And then we're using WebRTC here as well, basically to stream our audio and video from this presentation out to anyone who's logged in to the application.
So the other awesome thing about this is that you don't have to install a specific, or you don't have to have a specific operating system for this to work. I mean, the idea of the great goal of a WebRTC is that you are going to be able to just not having to install not even a plugin for this technology to be available for any application that wants to use it. So in order to explain the potential of this, right now there is more than 1 billion of endpoints, WebRTC endpoints, without them having to install anything particular to have the technology start working. So you can see the size of the opportunity that we have here, all the immense size of different applications that he can do. And in that regard, maybe just to explain just one API. Because in WebRTC we have 3 APIs. The API that gets the streaming, the API that initiates the signaling and then start the peer-to-peer communication, the RTC peer connection, and then we have a third API. It's called the RTC data channel. So we not only are able to communicate audio and video, but we can also send anything in the format that we want. So that means that we can have many other applications too, like gaming, for example. So this is just one example of the first API, the get user media. With this one, we can get, we can specify, in this case, in the constraints, the first argument in there, or the first parameter, which is audio and video. With that, he can get the stream in there, in the GOT stream, and then he can play it afterwards. So that's the first API. All right, but just there was the first example of how to see code in here. Now, which applications we have here? There are many. We can talk about contact centers in this example. Maybe Arin can explain more in detail this one.
So there's so WebRTC, by the way, just to be clear, is available right now in Chrome, Chrome, Firefox, and Opera. It's not in Safari or IE yet natively. But still, just the combination of those browsers gives those billion endpoints that are potential users of WebRTC now. And so there are a lot of different applications that companies are starting to deploy and try with WebRTC now. Probably the most common one is some sort of a customer service application, a contact center application. So this example, what this company, Wildix, has done, European company, is on their Contact Us page. You may be able to barely see there's a little green circle here that this person's available to call right now. This person has a red phone because they're on a call right now. So if I want to contact them for a question, when I click on that, it goes directly into a tool that they built using WebRTC for doing a video and text chat there, right? So that type of use case is the most common application of WebRTC right now that's going into production as some sort of customer support tool.
Something about the endpoints and the reason that this is getting so popular or so available right now is that besides that, I mean, the fact that we have Chrome and Firefox and Opera working on that, also Qt, this cross-platform thing, is now adopting the Chromium web engine. So now that's more numbers that makes the 1 billion even more bigger. Of course, the video conferencing, the thing that we were just doing before, we can do telemedicine. The amount of applications in here in telemedicine is huge as well.
And one thing I want to add about that, I'm sorry to interrupt you.
Sure.
One of the things that's really attractive for using WebRTC in applications like telemedicine is that the peer-to-peer channels are encrypted by default in the standard. And so that means that whereas before, you could have built a video chat tool and built a telemedicine tool, at least in the US, you've got HIPAA compliance and privacy concerns and tons of regulations around that you have to get. The nice thing about WebRTC for that use case is that because that communication is encrypted, there's less concern. It doesn't make you automatically HIPAA compliant, but it will certainly help you become HIPAA compliant with an application because you can say, yes, the doctor is conveying patient information outside of the hospital network, but it's on a peer-to-peer encrypted channel. There's no intermediate media server that could do any sort of man-in-the-middle snooping or recording of the information. In theory, at least, it's much more secure. So that's an interesting space for this to be used.
Yeah, that along with insurance claims and or the fact that you can have dashboards. So the amount of information that you can make available to everybody is awesome. As I was mentioning to Amy. Now maybe he can go ahead with these other examples that he have in here, like this video game. Maybe you can talk about this one.
The interesting WebRTC, the video and audio chat is the most obvious application of it, but the data channel is starting to get more attention as well. And this is where I think there's going to be some really innovative stuff. I mean, the idea of putting video and audio chat as in-context communication directly into your data dashboard is somewhat intuitive, and we can see some value in that right away. But then if you also think about how could we use this data channel, there's some innovative stuff you could do. So in gaming, you could certainly use it for the peer-to-peer communication between players in the game, so that you're communicating, coordinates, where I'm aiming my gun, all that sort of stuff, only between peers who are, maybe in the same part of the game, perhaps. And let me speak briefly to Peer CDN, which is a really interesting application in the data channel. They were bought by Yahoo in December. probably the first big purchase of a WebRTC-based technology company. And what they do, and some others are doing now as well, is use WebRTC's data channel as like a peer-to-peer BitTorrent between users on your site, so that if David and I are both on Yahoo's site, instead of Yahoo serving the static assets to us or using their CDN to serve those static assets, if our browsers are WebRTC compatible and Pure CDN can set up a connection between us, the static assets will get served to my browser from him, and Yahoo didn't have to host it on their servers, and they didn't have to pay their CDN. So even though WebRTC is not available in all browsers yet, if you can just take a fraction of the traffic off your website using a technology like that, for a big company, you can imagine that adds up to big dollars pretty quick. So that's an example of some innovative use of that data channel, and I think there's going to be a lot more interesting stuff coming up there.
The other point is that remember that WebRTC is a big umbrella of specifications that were being currently implemented in these browsers. But the fact it is freely available specifications out there, that means that you can do your own implementation of those specifications. That's why you can find out there Objective-C and Java bindings implemented. So that opens the door to make a way more interesting applications for this. And I think I will be giving you the full stage now.
So that's the quick basics on what WebRTC is. Any questions so far before I kind of tell you a few of the things that we've learned in working with this for a little while? Yeah.
You were saying that you had to allow a WebRTC connection. Is that only because you're using video, or for the data channel, and you still have to, the user still have to click allow?
The data channel you don't have to click allow, but video and audio you do.
Okay.
Is it the case that if it's an SSL website, after you click allow, it remembers that, and it doesn't have to happen again?
Yes.
Okay.
Yeah, and
It's verified.
yeah, and one thing that we haven't mentioned yet about WebRTC is you can use it also for like screen sharing application and stuff. So this tool, Alan, I've got you on the monitor now, by the way, just to warn you. This tool is a peer.in, which is one of many video conferencing tools that are free and have been built based on WebRTC. This one I particularly like, seems really easy to use. And yeah, Alan, actually, I see you put in the comments here, the permissions are persistent if you're under SSL. So he's agreeing with that statement as well. But also, if you're under SSL, you can do screen sharing through that. And so that's one thing peer.in just recently released, and a lot of these tools have as well. So that's also interesting when you think back to that customer support use case. That's a very common one with WebRTC right now, is you can build your own sort of Amazon Mayday style functionality where when someone's on your site and they're having a problem, if you have them click through to your customer support right away, you can not only have a conversation with them, but you can also get them to share their screen with you and see exactly the problem that they're seeing on your website. So I think that opens up interesting possibilities. And in fact, some people have done, Amazon hasn't confirmed that Mayday uses WebRTC, but people have done analysis of the network traffic and confirmed that it's at least using parts of WebRTC. They've probably rolled some custom implementation of it. So that's probably perhaps the biggest deployment of WebRTC that exists right now would be the components in Mayday. I think you had a question?
How does this compare to some of the previous technology before WebRTC came out for doing customer support? For example, you see a lot of websites that have kind of similar functionality.
Yeah, I think the big thing about this is that it's native to the browser, if you're in the right browser. So there's there's no downloads that the user has to make, like a GoToMeeting or anything like that. And so it's built directly into the browser there. That's a big one. The peer-to-peer nature of it I think it's a distinguishing feature from a lot of those as well. Yeah.
Can you talk about the browsers like on iPhones or iPads? Because I have trouble using WebRTC even with Chrome or Firefox on iPads.
Yeah, it's not supported in Chrome. There's no, to my knowledge, there.
Firefox either on iPad.
Right, there's nothing on iOS that's any of the browsers that supports WebRTC natively within it. There are some companies coming out, like just last week, I think Temesis announced a framework that will allow you to use WebRTC in any device, in any browser. So they ported it basically to Safari and IE and iOS, and I believe some others have done that as well. From a purist perspective, it's not like pure WebRTC at that point, because what they've basically done is implemented the WebRTC standard as a plugin in those browsers so that when in the little webinar tool that we were showing, I said if you want to use it, use Chrome. That's the only place we're guaranteeing it works, right? But if I were deploying that as a production tool and it was important to me that IE users be able to use the app as well, then I would probably be smart to look at one of those tools like Temesis or TalkBox that will bridge that gap for you. You had a question over here, I thought? No? Yeah.
Do you know when, are there plans for WebRTC to support iOS and mobile Safari?
Yeah, well, it's the reverse question, unfortunately. When will Microsoft support the WebRTC standards groups are happy to have it in all the browsers. And there's certainly momentum from users and the development community for them to do that. And because this is gaining popularity despite the fact that it's not in IE and Safari, I think they will have to support it eventually. But Apple has to make that decision and Microsoft has to make that decision. The argument is that both of them potentially have a reason to see WebRTC as a competitive threat to FaceTime in the case of Apple and Skype in the case of Microsoft because they own Skype. So maybe they didn't want to encourage this at first. WebRTC is really being pushed by Google, so you've got that rivalry going as well. So there's a lot of politics behind it. Apple has recently joined the standards committee, and Microsoft has started to say, well, we like this other thing called ORTC that is better than WebRTC. So they're like in the discussion now, but anybody's, your guess is as good as mine exactly when they would support it. A year ago, people were saying 2014 they'll support it. Now I hear more people saying 2015 they'll support it.
Thank you. Maybe. Oh, sorry.
Yeah, go ahead.
What are the challenges you found around signaling? In particular, you're still having to talk to some sort of centralized coordinator.
Yeah.
Correct?
So that's actually a good lead-in for me to continue here, maybe, and I'm going to answer that in a slide or two here. Did you have something you wanted to add on first?
I mean, from a technical perspective, if you have to think in the technical complications let me put it this way: if you as a product manager or as a product person in your company you are realizing that you need to enable a video communication in your product, and you can think that maybe the pairing that I can use is peer-to-peer. This will be the right way to go, because in terms of technical requirements, that's something that will help you to go there easier without having to worry right away in the scale problems that you have to handle if you want to do it from zero and having a centralized paradigm to handle all the streaming between people. So that's maybe the point I wanted to make. If you are facing that situation, this is the way to go. And I repeat, you can also take a look at the implementations and the WebRTC implementations that out there in GitHub of on WebRTC and Java about that as well.
Cool.
Okay.
So we've got a few things that we've learned here over the last 6 months or so that we want to highlight. And great questions, by the way. Keep asking them anytime. We've got time. So the first big obvious thing you've already heard is that browsers are a pain in the ass with WebRTC because it's not supported everywhere yet. So the one thing that we have to do, this is some of the JavaScript from this application. In the top line there, we're calling get user media in several different syntaxes to cover several different browser types and making sure that we get some sort of a valid response from at least one of them. And if we don't, then we know that you're in a browser that doesn't support WebRTC. And so in that, so only if we get a non-null response to one of those, do we then actually call get user media. And that, when you make that call to get user media, that's what triggers that allow and deny bar in your browser. You have no control over that. That's purely implemented in the browser, but it's basically the same in any of those browsers. And if they hit allow, then you're going to get a stream returned to you through the callback. But if you don't get a stream return, then you know that they hit deny, and you need to handle for that somehow. But the fact that you have to deal with just a few browsers, despite the how much better those browsers are and how widely used they are, it's still something to keep in mind. So it's kind of getting to your question about the signaling here. For us, my background is in web development, but I'm definitely not a networking guy or a telecom guy. A lot of the people who are writing the standard are from experienced telecom developers, and so when they talk about ICE and stun and turn servers and all the signaling that's happening behind the scenes, they get that, right? I don't get that, and I don't want to deal with that. And I think actually that's the beauty of WebRTC, is that it's opening up these capabilities to a broader range of web developers and companies that don't understand or don't want to take the time to understand those networking standards. And so I definitely encourage you to look at one of the APIs. What we're doing in our application is PubNub's API. They're just one of many doing it. They're not paying me to say any of this. The reason we started working with theirs, and by the way, somebody in that text asked what does PubNub stand for. I don't know exactly, but I think it's just a play on the fact that they are primarily a provider of publish-subscribe real-time messaging as a service. So PubSub is another open source framework that's out there. Hey, I don't need to be in that meeting. And so that's where they started, right? And we've used them on other projects as a very scalable solution for real-time messaging. But then they also came out with their WebRTC wrapper, and so that's what we're using in here. And the nice thing about that is that it's handling the publishing of the streams for us and essentially the signaling for us, so that we don't have to know all the details there. And I have a separate little diagram here that kind of shows how it works for them in this application, the way we've implemented it. On the presenter side, when I click on someone's comment in this application, it does that get user media call to request my local video stream. Assuming that's successful, then it's going to publish what is basically just a text message. We're not publishing video streams yet here through PubNub's API to a channel called call. And we're passing it an action, calling, and we're giving the unique identifier for me as the browser, as well as who specifically I want to call. So if all of you were signed in to that webinar tool right now, all of you would receive this message on the call channel. You're all subscribed to it, but we've written the code such that the only person who's going to answer it is the one with the matching callee identifier, right? So that's a publish subscribe. You're pushing out to many. And that's typically how your signaling mechanism is going to work, because this is basically how you're discovering the unique identifiers between people. And then when they click allow in their browser, it publishes back on another channel called answer, which basically says, I accept your call. And again, we're passing along the unique identifiers for both the caller and the callee, the presenter and the attendee in our case, so that only those people are dealing with the code in our situation. And at that point, that's when there's a separate call to actually publish our streams through the PubNub API, which for us as developers looks very similar to any other type of publish message in their API, except that we're passing streams to it this time instead of a text message. So they're handling that for us, basically, which is definitely a good thing. And again, just to be clear, there are other companies that do that as well. Probably a few out here, as a matter of fact. Okay, any other questions on that? Yeah.
Well, are there frameworks that would allow you not to use a PubNub type service? I mean, do you have to use a third-party service like that, or are there ways to?
Well, you could set up. You have to have some type of a intermediary server to do the signaling, but it doesn't need to be a commercial provider. There, you can use like Peer.js or an open source framework and set up your own signaling server, right?
You can use Socket.io for doing this part.
Mm-hmm.
Yeah.
And this is one thing people sort of, I think, complain about at first about WebRTC, or it's at least a concern, is that it doesn't specify how to do the signaling. But that was done on purpose by the standards committee because every implementation of this is going to have a slightly different context of how we are aware of what other users are in our system and how we want to communicate with them. And so the signaling really is better left up to each implementation. And so they specifically leave that out of the standard, exactly how you're going to do that. So.
And the signaling between you and the PubNub is secure.
Yes.
Yes.
Yeah. Yeah, but that raises a good point for you to consider too. Is one of the things that I like about WebRTC is the fact that it's that peer-to-peer encrypted, right? So if I wanted to do something that's either financially sensitive about my company, or it's one of those telemedicine apps, I can feel like I'm doing this video chat in a way that hopefully the NSA can't snoop on me, or certainly your average person can't snoop on me in that situation.
During the signaling process,
exactly.
Then they could impersonate your peer person.
Well, once at least in theory, I am definitely. Although I live near the NSA, I do not work for them, and they definitely, it's my understanding that once you and I have that peer-to connection, they can't get in the middle of it, right? In the signaling, yeah, maybe they could impersonate it, but they would have to relay the traffic to you for us to not realize it somehow. But really the point I was going to bring up about the signaling is if, like in a telemedicine app, you're trying to get HIPAA compliance and you can't pass sensitive patient information, then you need to make sure that in your implementation of signaling, you're not passing patient name or social security number or something like that. You're passing some sort of anonymous identifier, because the signaling part is not necessarily secure unless you make it secure. Does that answer your question?
Yeah, it does. It does make me feel real secure. I was thinking more, the way you're discussing it's a little bit where you expect a person on the other side, and because of the context of the conversation, you'll know you're really talking to that person.
Yeah.
But if you were using WebRTC as a nightly data transfer,
right,
that happened in an automated fashion, then during the signaling phase, if somebody impersonated being the other side of that automated traffic, there'd be no human being to say, hey, that doesn't sound like John.
Right.
It would be very possible to just respond appropriately and acquire that information that was being
that's absolutely correct.
Considered confidential.
That's absolutely correct. So if that is important to you, you have to be very careful about your signaling. But once the connection has been established, it should be secure.
Yeah, I understand.
Yeah. But yeah, it's a very good point. One thing that actually we didn't really hear. Oh yeah, go ahead.
The presenter and the sender, could you have multiple only one peer?
You can only have one peer in a given connection. So if I want to have a chat with you and the other 3 guys in your row there, I need to have a separate peer connection with each of you. And each of you also need to have 4 peer-to-peer connections, one with me and then with the other 3 people by you, right? So that's where we were saying earlier, WebRTC doesn't scale by itself to large video chat conversations, because around 6 or 8 people, you're going to start to burden the user's devices too much with having to have basically a mesh network of peer-to-peer connections to everyone else in the conversation. So if you want to use WebRTC by itself, you should be doing it in applications where 5 or 6 people at the most are what you want in there, and you're okay with that. If you're trying to build something that allows larger multi-party video calling, then you should look at using one of the commercial services that will basically, it's not pure WebRTC anymore, but you would have a WebRTC peer-to-peer connection to their media server, which would then aggregate your stream with other users' streams and have peer-to-peer connections with each individual user, so that can now scale because each person only has one peer-to-peer connection with this media server. But if you have privacy concerns, right now you have this intermediate media server that someone could potentially snoop on, right? So you've changed the dynamics there, but maybe that's okay.
Dynamically adapted the traffic when you encrypted video and audio. If the traffic goes, the traffic degrade, or if the traffic is not as
When you establish the connection, you can establish which basically level of service you want, and we're just picking the smallest level of service, and that's
that's fixed.
yeah, that's right.
Can you change that after the connection has been established?
Not to my knowledge. Not to my knowledge. I don't see anybody disagreeing with me who's used it before in here, so we're going to go with that. We've got about 10 minutes left in the session, so let me flip through a couple other things here. One thing very common in any demo of WebRTC is echoing, of course. We surprisingly did not have that problem this morning. But you do need to keep that in consideration. Because I'm streaming my video as presenter here to other people who are in this tool and my audio to them, I need to make sure that I'm muting the playback of that within my laptop so that when I'm doing calls, I'm not creating echoes. So you've got to think about stuff like that. And then you also need to, and Mariana, I'll ask you to come up and say a few words here, think about some unique UX and design considerations.
Hi, everybody. So we've been talking a lot about WebRTC and how cool of a technology it is. Some things to keep in mind when designing for real-time communications, and it doesn't really have to be WebRTC. You have to think, is this the right technology for the audience and the activity that I want to support? So WebRTC is great, but do I really need to include it in my product? Is it really going to enhance the experience? Is one of the most important questions that you have to ask. The second thing that you have to keep in mind is feedback. I don't know if you noticed when Arin was trying to connect with Alan, they had to use Skype because the way we built the tool, it doesn't really let you know if the connection is working or not. You're just calling somebody. So that's something that you need to keep in mind, is that WebRTC depends on the bandwidth. It depends on the browser that you're using. And so feedback is very, very important. It's one of the lessons that we learned early on and that I would like to share with you. Another thing that you have to keep in mind is that with RTC and with things that are happening in real time, you have to be able to control how the information is coming in, how you're going to structure, how you're going to give it priority. So for example, we've switched to a full screen view here so that the comments and the ratings are not in the way of the presentation that we're giving. At one point in the conference, we wanted comments to be the highlight, and in the second part of the presentation, we wanted the actual presentation to be the highlight. So you have to give the user this option of being able to switch between information that's coming in constantly or information that you can select when to view it and when not to view it. The fact that it can come in real time doesn't always mean it has to come in real time. And the last consideration that I'm going to give to you is always think about graceful degradation or progressive enhancement. Not all browsers support this. So if you're going to implement a tool, think about all the users that don't have this capabilities yet and how you're going to be able to support that and still have a good experience and still have a good activity around it. At least for the time being, that's something that we have to think about when designing for WebRTC. So thanks.
Thanks, Mariana. She gave an hour version of that talk in Washington, D.C. on Monday, so that was the abbreviated version. Like she said, you know, dealing with drop connections is really important and something we've definitely struggled with in here. And also, as she mentioned, I'd like to jokingly call those Skype conversations as manual handshaking, where we're not actually trusting our own tool or we're not trusting WebRTC yet. We're using something else to keep communicating. And so, you know, that should be your goal in designing this, is that the day when you stop ever using Skype for manual handshaking of testing things, you know you've got a solid app. I think this is the last one, perhaps. The other thing to consider here is, because you are doing, we're not specifically in our code, but the PubNub API in our case, or you know whatever API you're using, is negotiating traversal across NATs and firewalls for you. This is not necessarily going to work everywhere. So I gave a version of this talk at a company in New York City a few weeks ago, and on their guest Wi-Fi, no call on WebRTC would work at all. They, you know, had the video streaming basically, I guess, shut down within that, right? So that's a concern if you want to build a WebRTC-based app for a big corporate enterprise, right? What are their network policies? Can you actually do a call? You know, so before you go write the code, pull up one of these tools like Appearin on their network and see, can you even do it, right? Or are you going to have to get special permission from them? So that's definitely something to keep in consideration. And that's basically it there. We've got a couple minutes for other questions. We have a ebook that we've published about this that basically walks you through how we built this particular tool and takes you through some of these technologies along the way. So you're welcome to check that out at realtimeweb.co. And the other thing is we do a weekly newsletter on called Realtime Weekly, realtimeweekly.com, which highly encourage you to check out. Lots of content on WebRTC, as well as published subscribe networks, real-time applications and frameworks in general. So that comes out every Monday afternoon. And I'm going to switch over to Alan. I didn't really give you a chance to chime in here if there's anything else you want to add before I open it up for the last couple of questions here. Oh, you're muted, or maybe I've muted you.
I did. That's another thing to take into consideration.
That's right.
Yeah, you did great.
Awesome. I paid him to say that. Okay. All right. Well, prove him wrong. What other questions do you have?
So I've noticed there's a lot of inconsistencies in support of the data channels. Is there anything? Have you guys made a lot of use of those? Have you found any like lowest common denominators that work across browsers?
Yeah. So when the data channel standard first came out last year, it was only working between like Chrome to Chrome. You couldn't do Chrome to Firefox. But now it does work, my understanding, within any of those three browsers to each other. So you can do a Chrome to Firefox data channel, is my understanding.
There's still some inconsistency on the binary piping formats. Do you know if that's...
I don't. We haven't dove into the data channel enough to run into that yet ourselves. But I definitely believe you, because the data channel has been kind of the trailing edge of those three channels that WebRTC supports in terms of adoption in the browsers, as well as just adoption and use cases and people coming up with cool ways to use it.
Just to clear that, there's a
Please.
limitation on the binary.
Say again. Sorry.
There's a limitation on the binary.
Okay.
So you could only go a certain size, and then it just pops
In
out.
terms of the amount of data that you transfer. Okay. And is that consistent across the browsers, or do you know?
I mean, as far as I've seen, it varies here and there.
Yeah.
There's no like real set.
Okay.
It's on their roadmap to fix it. So
Okay.
we can use a different program.
Okay, great. In case anybody couldn't hear that, there's a limitation on the amount you can transfer in the data channel right now, but it's on the roadmap to fix that. So thanks, that's helpful.
I don't know what they are.
Is it like per session?
No, yeah, it seems to be just per session. Like you try to send a huge file and it doesn't do it. So, but
Then
it
after,
does well.
Then if that fails, you try to send something else.
Yeah,
Something else.
no, I see what you mean. Does it
Yeah.
kill it? I don't know. That's a good question, though. That's a good question. We usually give it up after that.
Yeah.
Have you dealt with any way of compression on the streams for both audio and video? Is there any way to like hook into the actual binary and
We haven't dealt with that. To my knowledge, I don't think that's exposed through the API that we're doing, or are you saying you would do that through the?
You probably could through web audio context.
Oh, okay. I haven't. Alan, have you dealt with that at all in our work?
What was the question again?
Have you dealt with any compression on the streams?
No, we don't, but there's something that you could do. Let's say you could detect what the bandwidth is of the client, and depending on what that is, you could say, okay, instead of sending HD through the stream, when you're requesting the stream via the get user media, you could say, okay, this user doesn't have a good bandwidth, so we're gonna use QVGA instead of HD. So that's one thing that you could do, and go from there. So if you detect that the browser doesn't, the user is not behind a very good bandwidth, you could say, this is how I'm gonna move on from now on.
Alan, do you happen to know if you can change that on the fly after you've made a connection? Someone asked that earlier, and I think the consensus here in the room was you cannot, but...
We haven't tried that.
Yeah. Okay, other questions? Yes?
Is there any timestamp metadata that goes along with the audio video stream, or is data channel-wise?
Alan, I think you would know the answer to this one. If there is any timestamp data that goes along with the stream, so this, don't mention our client's name, but I'm thinking this is probably relevant to the work you're doing for one of our clients in WebRTC right now. I assume you're trying to think about syncing up the streams with each other somehow. Yeah, yeah. How do you sync the audio streams?
No, we don't have to do that. Like, even though when you request the stream to the browser, you could get the audio tracks and the video tracks, but since they're in one media stream object, they're synced, so you don't have to deal with that. But I don't see any timestamp or metadata being passed.
Well, let's say like I wanted to try and write the audio stream.
Mm-hmm.
Would there be timestamp metadata that would go along with that that's coming from the stream, or would that be a local on the machine?
Yeah, I think his question, Alan, was not syncing the video and the audio streams to each other, but if you and I are sharing our audio streams and perhaps collaborating or manipulating those streams, is there any timestamp on each of our individual streams that would help you make sure they're in sync?
No, not that I know. And what we do in other projects where we use the WebRTC is when people are sharing streams, we just let them do that in the browser. We let them set the start and end of the track.
Yeah, that's right.
So we don't let the application to behave based on any metadata that we're receiving on the stream.
Yeah, so I don't know if that made sense. We basically are letting them manually slide the tracks around if they need to sync them a little bit. Okay, any other questions? Great questions. Thanks so much for coming. There's a break after this, so we're happy to hang around and talk more with anybody and love to hear more about how you're using WebRTC. And realtimeweekly.com and realtimeweb.co. Check us out. Thanks a lot. Thanks, Alan.
Bye-bye.